Hey everyone, thanks for joining us today. I'm Ryan Sanders. I'm the Senior Director of Product and Customer Marketing at Keyfactor. I'm also joined by Ian Curry, our Director of Strategic Initiatives, and Ian came to Keyfactor through the acquisition of InfoSec Global earlier this year. So great to have you here, Ian. Ian, how's it going?
Great to be here. Thanks, Ryan. It's going great.
Awesome. All right. So yeah, if you're not familiar with InfoSec Global, they're a leader in the emerging cryptographic posture management space. So their AgileSec analytics solution is what we're going to show today, and it's all about giving you visibility into your cryptographic landscape. And that's something, security and risk teams are really starting to prioritize. Organizations need visibility not just into keys and certificates, which there tends to be more maturity around the management of those, but across their entire cryptographic estate. That's being driven by different factors, whether it's, audits, vulnerability management, quantum migration being the big one ahead. But today we're going to give you a quick look at what cryptographic discovery looks like in action, and how it helps you gain that visibility and control that you need. So with that, we'll keep things short and sweet today, just 30 minutes. We're going to try and stick to that timeline at least. But if you're interested in diving deeper after the session, we'd love to continue that conversation. So just keep an eye out for a quick poll that's going to happen at the end, where you can let us know whether you or your team would like to follow up with us. But here's what we've got lined up. So first off, it's going to be a quick overview of what we mean by cryptographic discovery and inventory. I'll go through that. Then Ian is going to take over and he's going to walk through a short demo of the AgileSec platform. And then lastly, we will wrap up with some Q&A, at which point, hopefully we'll be able to allow you all to unmute yourselves and ask questions if you'd like as well. So feel free to drop your questions in the Q&A, but happy to have you unmute at the end if we'd like to have more of a conversation. All right, so before we dive in, just want to set the stage for exactly why we're here today. So at Keyfactor, everything that we do revolves around digital trust, making sure that identities in the form of certificates behind your devices, your workloads, your software, that they're secure and reliable. And that's really the core of our PKI and certificate lifecycle management solutions. But today, the challenge goes deeper, right? It's not only just about certificates, it's about understanding the full spectrum of cryptographic assets that power your infrastructure. And to do that, you need to see things from multiple different angles. And that's really where Keyfactor brings something unique here, which is that combination of deep discovery with passive network monitoring. And together they give you that visibility into cryptography wherever it lives and also wherever it's being used. So with deep discovery, we'll talk about that today. You can start to uncover some of those cryptographic assets that might be hidden in source code, in applications, in endpoints and infrastructure. And then with network monitoring, you get that real-time view of how cryptography is actually being used by observing traffic over the wire. So together, these capabilities really give you that broader visibility and richer context that you need to understand what's really going on. Finding certificates in more places, understanding the systems and endpoints that they interact with, and then most importantly, extending visibility beyond those certificates, as I said, to things like keys, tokens, libraries, algorithms, and protocols that you see on the bottom there. Every one of these assets matters because they're all interconnected and interdependent. If one is weak, if one's exposed or misconfigured, it can compromise the ecosystem around it. And this becomes, of course, even more critical, as I mentioned earlier, with the move toward quantum safe cryptography. So to migrate successfully, you really need that visibility into every asset, not just some, but all of them. And ultimately, the goal of these solutions is to give you that position of control, right? Where you can have that centralized visibility of otherwise unmanaged or untracked assets, whether they're buried in source code, sitting on your endpoints, embedded in applications, third-party applications. You can start to proactively monitor and identify risks or vulnerabilities in that landscape. Things like unencrypted traffic or exposed keys or even deprecated cipher suites and protocols, things that expose your infrastructure to risk. And then lastly, you can start to take action and triage those risks, whether it be through an automated ticketing system for more complex issues that require human intervention or a more automated process through certificate lifecycle automation with Keyfactor Command and automating renewal and provisioning to replace those certificates. So that's really where the power of our overall platform comes into play by integrating these discovery and inventory capabilities into the Keyfactor platform, we're building a more complete solution for digital trust. And that starts with visibility on the left there, discovering and assessing your cryptographic assets across your infrastructure. Then comes the trust, right? That infrastructure that underpins trust in your organization being signing, cryptography, and PKI, and ensuring that those are scalable, flexible, and quantum ready. And then lastly is the lifecycle management, automating the lifecycle of certificates and SSH identities across your environment. So that's just a quick look at the full picture. But with that, I'm going to pass it over to Ian, and he's going to dig into specifically around the AgileSec analytics platform and the discovery and inventory capabilities behind it.
Great. Thanks so much, Ryan. That was a fantastic introduction. Yeah, the platform that we're talking about here today is called AgileSec Analytics. It is the broad, as Ryan said, sort of deep discovery capability that organizations need to really get a handle on the cryptography that they have, that they depend on every day. Cryptography is really, a set of amazing capabilities that I often think of a lot like electricity. It's fundamental. Everybody needs it. Almost nobody understands it, but if it doesn't work, nothing works and
Right.
everything just shuts down. So it's really important that organizations, for many reasons, get visibility. So let's go on to the next chart and we can talk about what some of those reasons are. I'm going to start right in the middle of this chart and I'll explain why. Many, many, many people come to me and they say, Ian, we need to talk to you about PQC, post-quantum cryptography and migrating to post-quantum cryptography and PQC readiness and planning and all of that. And I say, absolutely fantastic. And so we sit down and we have a conversation and a demonstration like we're going to go through here today. And for many of those conversations, they want to see the technology live in their environment, and so we'll move to a demonstration system in their environment. And as soon as they do that, they immediately revert back to the left-hand side of this chart. And the reason why is that as soon as you go to discover cryptography in your environment, all of a sudden you start to see things you've never ever been able to see before. It's sort of that simple. Cryptography has really been quite static for the past 30 years, and that's allowed developers to take cryptographic algorithms and embed them deeply pretty much in every single piece of technology that you use. It's hard to think of a piece of technology that you use today that's valuable that doesn't incorporate cryptography. Everything from single sign-on authentication to encrypting stored data in the cloud to vaults and all kinds of different technologies. So people come looking for PQC migration. We'll talk about that later. But once they deploy our technology, immediately they begin to see vulnerabilities in their infrastructure that they haven't seen before. And that's obviously really important because vulnerabilities are weak points that can be exploited by attackers. So that's one really great use case is using cryptographic discovery to understand the strengths, where you're good, where you're operating really well. That's also really important to know, and where you're maybe not operating as well as you might have assumed that you are. Okay. And then the second area is cryptographic compliance. Compliance is an incredibly important topic in cryptography and in many industries because of the clear understanding that cryptography underlies the health and lifeblood of that industry, just like I was talking about, like electricity does. They understand that you require compliance. And so there's numerous regulations, different regulations in different industries. And that's one of the things that cryptographic discovery can also show you, which we'll talk about in the demo, is what cryptographic objects in your environment are compliant with the policy that your organization is trying to follow and which aren't. Okay. Then there's PQC migration, and for sure, getting a good, broad, deep view to the cryptography going on in an organization is fundamental to understanding how that organization is going to plan and prioritize the migration to post-quantum cryptography, which is, really the way of the future, and along with agile cryptography, meaning you're not dependent on one algorithm or another algorithm. You're dependent on a way of changing algorithms in a seamless kind of rapid manner so that if something happens with algorithms that you're using today, you can switch to another one tomorrow. PQC migration is a huge topic. And then, sorry, if we can just go back a second. Ryan.
Yep.
And then there's just finding cryptographic threats. One of the really cool capabilities that we offer customers is the ability to find, for example, keys that are not properly protected. What I call keys in the wild, keys that are just sitting there. Again, the organization is probably completely unaware that there's keys that are sitting around that are unprotected, but there have been some huge attacks in the past that have really been based on the fact that keys somehow got into an unprotected state and were used by very powerful hackers to go and do things that an organization would never think they could do, because we all know that somebody who has a powerful cryptographic key, particularly for authentication, will be able to sign as a very powerful entity and basically move around a network and do all kinds of things. And then there's supply chain. And this is also a very important use case, because this allows you to understand the technologies that you are using to drive your business with your supply chain partners. And that could be code that you write. It could be code that you only get as compiled applications, so you don't have the source code to it. We can dig through all of those kinds of technologies in your environment and in your supply chain partners' environments, so you can get a clear understanding of how your supply chain is going to move to post-quantum cryptography as well. Because if you move but your supply chain doesn't, you're going to kind of be on an island and stuck. Okay, great. So those are some use cases. What Keyfactor offers is a platform that's focused on doing discovery, creating an inventory, doing analytics. That's what we're talking about here today. But then also offering customers the ability to remediate problems, and that's through Keyfactor's existing products, but also the ability to do this agile cryptography that I mentioned before. We won't talk any more about that today, but I'd be happy to talk to any of you about that in the future. So those are two huge parts of this platform. Before we dig into any more details, the other parts of this chart that are important, Ryan already spoke about the different types of cryptographic objects that are listed across the top of the chart. So identities/keys, certificates, tokens, algorithms, libraries, and protocols. It's really important for everybody to be thinking about cryptography across all of the different types of cryptographic objects that exist, not just a subset. I think Ryan said it quite well. If you do really well with keys and certificates, but you're unaware of the status of your libraries and your protocols, well, that's where the attacks are going to happen. If you have a vulnerable library that's out of date by 6 years, well, that's subject to attack. That's where the attack's going to happen, and you're not going to be aware of that. So it's very important when you think about cryptography that you think about all these different types of objects. And I know, having spoken to very knowledgeable people in cryptography over many years now, that it's easy to miss one or two of those types of cryptographic objects when you think about cryptography, because maybe you're an expert in certification authorities and certificate lifecycle management, but you've never written an application and you don't worry about libraries, for example, right? But having that holistic view is very important. At the bottom of this chart, it's also important to understand how a solution integrates into your ecosystem, because modern digital infrastructures are incredibly complex, and you need the ability to, dig into the different digital environments and find the cryptography that's embedded within those, whether that's hardware security modules like those from Thales and Udimaco, or, certificate lifecycle management systems and certificate management systems like Keyfactor, cloud systems like AWS and Azure, leveraging EDR systems like CrowdStrike and Tanium, and software development environments like GitLab and GitHub, for example. You have to be able to dig into those environments and find the cryptography that's in there. So we'll talk about that a little bit more, but that's also important. So the AgileSec analytics platform, this is the discovery and inventory platform. I'm just going to take a minute to explain to you how it works, because then when we get into the demo, you'll be like, oh, that makes sense. Now that I understand how it works, you'll actually see how the system fits together in the actual interface that administrators see. If you think about this centralized component, the AgileSec platform, that has a database, an analytics engine, a user interface component to it, and a reporting engine. Okay, but that's where the objects go, where they're stored, where they're analyzed and reported on, but that doesn't tell you how the objects are discovered and collected. The way we do that is through technology that we call sensors. And the first one we're going to talk about here is in the top left. That's the network sensor. We actually have different types of network sensors because um, there's different ways of discovering cryptography over a network. The first type is what we call active network sensing, and that allows us, our customers give us a range of networks of addresses to interrogate, and we use those addresses to go and discover all kinds of information about SSH and TLS. We find keys, we find certificates, we find the protocol versions, and we find all the algorithm cipher suite configurations that are done in those across those different addresses for SSH and TLS. And that's highly valuable to people because those are incredibly important cybersecurity components in all modern infrastructures. And knowing whether you are compliant with what you want to have as a configuration or not compliant or some of both is very, very valuable to organizations. So that's sort of active network sensing. Then we also have passive network sensing where, traffic on the network can be captured and analyzed, and then we can show you connections. We can show you what's actually technically happening on your network, not just the configuration, but how those configurations are actually being enacted in connections on a network. So those types of objects that we're finding, every single type of object that we find, every single object that we find rather, is sent back securely over the network to the centralized inventory where it's analyzed and scored and then presented to an administrator so they can see where their problems are and they can prioritize remediation activities. So that's the first type of sensor that we use called the network sensor. The second type of sensor is called the host sensor. And that is used to analyze files and images in cloud workloads. And that you can use to scan all the files on a disk. You can scan all the components of a cloud workload. You can take an image of an OT device or an IoT device, and you can scan that to find out all of the cryptography that are in, those types of devices. Very, very powerful. This type of capability not only has the capability to find, you know, files that are storing keys and certificates, for example, but also all of the cryptographic objects, algorithms, embedded keys, embedded certificates, tokens, and libraries that are used inside compiled binary object code files, applications that you get from third parties. So we can dig through those technologies and show you what you're using, even though you don't have the source code for it. Okay. Very valuable, very powerful. Typically we can find, many tens of thousands of cryptographic objects or thousands of cryptographic objects by, doing a scan of even a small number of servers in an environment. Our third sensor that we're going to talk about here quickly is the source code sensor. That does pretty much exactly what you would think. It digs through source code files in source code repositories across multiple different types of source code management systems and programming languages to find all of the different types of cryptographic objects in use in the source code that's being investigated. And again, here we find keys, certificates embedded in files. We find all of the algorithms there that are there, embedded tokens, and also the libraries that are used. And we again report those back to the centralized platform where they are scored, where they're analyzed and scored and reported on. And then across the bottom, I have some, pretty general key management, key and certificate management components that we can go and interrogate, like PKIs, key management systems, hardware security modules, and we can go into those environments and discover the cryptographic objects, mostly keys and certificates, and report those back again to the centralized platform. There are many other types of sensors that we'll have, which we'll briefly touch on as we go through the demo. But now I think you get a sense of, cryptographic inventory isn't created out of magic. You go into the environment, you dig the objects out, you put them into a centralized place, you analyze them, and you help a customer understand what they have and where they're not compliant, what's vulnerable, where they're more ready to migrate to PQC, where they have to do some work before they can start that migration, and so on. The types of reports that you see, which we'll get into in a minute with the demo, look like the ones on the right-hand side of this chart, where things are shown in different colors. You can click on any segment of any graph And you can dig right down to see the individual data on each individual cryptographic object that is of interest to you. Okay, next chart, please. We talked quickly about some of the integrations. I won't go through this chart in any detail, but you can see, some of the integrations that we have already done. There are many more, but they cross, pretty much all the different major components of a modern digital infrastructure. And one thing that's of interest to people, sometimes people say things to us like, well, I already have some data on TLS and, can you import that into your system? We say, of course we can. So, all those types of things are there. When something is scored, let's say as a severe vulnerability, we can automatically report that out to an IT management system, problem management system, a ticket system like a ServiceNow, for example. So that's, a quick run through of the types of integrations that we have. Now we'll just jump into the demo.
Awesome. Thanks, Ian. Yeah, and as you switch screens into your demo, I think it's really interesting just, tapping into the existing sources of cryptography that you already have. I think there's a lot of, capabilities within an organization. You mentioned like CrowdStrike being one, network and vulnerability scanners. They're capable of finding cryptography. So leveraging those tools, tapping into them and kind of connecting the dots quite literally in the diagram that you showed. I think that's an important step that, organizations need to take, is not just deploying new sensors. Those are important too, but tapping into the existing infrastructure that you have.
Absolutely. Yeah, I mean, there's so much there. Typically, when an organization deploys our technology, again, even on a fairly small scale to do, proof of concept, they are always 100% of the time shocked at the scale and scope of use of cryptography in their environment, even though they're very knowledgeable about cryptography already. They're still shocked. So what we are looking at here is the dashboard of the AgileSec Analytics home screen that administrators get to see. All of the access to this can be role-based access control, so you can very tightly control what any particular administrator can see. But I'm just going to scroll down and show you, the types of information that you can see based on the sensors that are used in the collected cryptographic objects. Up in the right-hand side, you can see the number of cryptographic objects total, the number of unique cryptographic objects, because many cryptographic objects are not unique. And you can see across 501 systems, we've got many tens of thousands of cryptographic objects found. What this chart is here, it's showing the different runs over time that collected the different cryptographic objects that are now in the inventory. So again, this isn't something that, people do 1 week or once. It's something that evolves over time, and you just keep adding more and more to your environment. It's not a one-time operation. It's a long-term collection operation. So then we can show you down here all of the different types of cryptographic objects. Again, if I wanted to see this red section on cryptographic protocols, I could just click on that little segment of that donut chart and we could dig in there. This is showing you all of the different types of sensors. I mentioned that we have many types of sensors that collected the different types of objects and how many were collected. This is the host sensor that's collected, almost all over 34,000 cryptographic objects. Here we're doing cryptographic object discovery in a backup, in a Veeam backup. So we can even do that kind of capability. Here we're doing source code analysis, network analysis, again, network sensor. Here's a key vault from Azure. Here's something that's doing passive network analysis. Again, looking at the traffic going over a network, more source code, more network analysis. So again, very, very comprehensive capabilities that we have already. Here's the data being presented based on the CMDB. So we can take an organization's CMDB, we have integration with ServiceNow CMDB, and we can show you your cryptographic objects based on the way you look at your network based on your CMDB categorization. So we can show you things that are in development, things that are in production, things that are in staging. We can then go look at the data based on a system perspective. So, right here, we can go and we can look at this remote sensor hub. We can see, oh, there's 4 very serious vulnerabilities here, 16 pretty bad ones, about 2,000 ones that, are not great, but are okay. And then 1,000 that are totally compliant. Okay. So you can see more and more of the systems here. Then you can go and look at the source, the type, the environment that we discovered the cryptography from: hosts, a backup again, source code, network, da, 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 da. Okay. We don't have tons of time here today, but hopefully you get the idea. And then you can see here, we're looking at the different types of problem areas where cryptographic objects fall into. So simple ones like expired certificates, weak algorithms, intermediate CAs or CAs that have long life CA certificates, which can be a problem in many organizations, TLS issues, weak key sizes. Oh, here we're looking for, existing PQC algorithms and so on. Okay. Insecure protocol versions. If we wanted to go see insecure protocols, let's go look back at this remote sensor hub and just click on this red segment of that graph. Again, we don't have tons of time, but what that's going to do is it's going to pull up these 4 high priority issues, and we're going to see that they were all found by the network sensor. You can see that right here. And in fact, there's multiple different problems in those 4 serious problems. Okay. So while there's 4 issues in that piece of technology, there's actually more than 4 problems. Okay. And there's insecure ciphers, there's insecure key exchange setup, there's message authentication code that's not good, and so on. So if we want to go look at insecure ciphers, which is a good example, we can click on this. And here we'll go down and you can see exactly what's going on. So here are the 2 systems. Here's protocol insecure cipher. Here's some standard version issues. And here's more, again, insecure ciphers. So let me show you the kind of data that we collect when we're talking here about protocols. Remember, protocols is just one type of cryptographic object. So when we look and expand that, you can go down and you can see we are showing the customer exactly where this object exists in their network. There's no mystery where this problem lives or where to go to fix it. Okay. Again, I'm having to go quite quickly today. You can see the scoring. Here's a score of 10, priorities 3. Those are both as high as it gets in the scoring system, which you can change in any way to meet your needs. Okay. So the analytics engine that I'm talking about here, you can change the parameters of that in any way that you want at any time to score the objects according to what's high priority for you. Let's go down here. You can see here's the cipher suite that's configured for this instance of a TLS server. Everything that's red is completely non-compliant and vulnerable according to what this demo environment has set up. The gold ones are, again, not compliant, but not way out of serious, don't have a super serious vulnerability. Here, probably the problem is that it's using SHA. Okay. But you can see here's the list of all of them, all the ones that are clear, those are good. Here we're giving you the list explicitly of the ones that are highly problematic and how it was found using the network sensor and so on and so forth. It's a Windows server, a lot of information. Who owns this? It's the ISG operations team and so on. So you can see there's a lot of information there. We only had time really to look at a single dig down deep, but you can imagine we're collecting that same type of information about keys, certificates. This was really about protocols, but also about tokens, libraries, and all other types of cryptographic objects that exist, and the algorithms that are in play. Okay, so that's that. Hopefully you had a quick understanding there of the system, but that's the kind of capabilities you get with a broad, system like ours, our platform that does deep cryptographic discovery.
Awesome. Thanks, Ian. Yeah, every time you go through that, I learn more about this, so it's incredibly helpful for me as well. But yeah, really appreciate the rapid fire demo, and that's where we want to open up to the audience and make sure that you have the opportunity to dig